Widgets are produced by a machine which is set to produce them with a diameter of 0.620 millimeters and a standard deviation of 0.018 millimeters. After servicing, the Quality Control Manager is concerned that the mean setting has changed. He decides to do a test at the 5% level to see if this is the case, using a sample of 100 widgets. Suggest a model and hypotheses and define the critical region. So, we're going to have x as a normal distribution with 0.620 as the mean and 0.018 as the standard deviation. The means then, for a sample of 100, would have the same mean, but the variance is now 0.018 squared divided by 100, and therefore the standard deviation is 0.018 divided by 10. The null hypothesis is the mean has not changed. The alternative hypothesis is that it has, but we don't know in which direction. So that's going to lead us to a two-tailed test. And if we're going at the 5% level, that means we're going to have 2.5% at each n. So bringing in the calculator and inverse normal, we want this area to be 0.025. The sigma, as we mentioned, is 0.018 divided by 10, so that's going to be 0.0018. And the mean is 0.620, so 0.62. And that gives us 0.616. Let's just leave it as 616. And that means that this will be 0.624, just symmetric. So I've gone down 0.004, go up 0.004. If a sample of 100 widgets has an average of 0.615, what would you conclude? Well, 0.615 would be here. It would be in the critical region. 0.615 is in the critical region, so there is evidence at the 5% level that the mean has changed.